All right, to end Unit 3, we're actually going to take a look at how we can use similar triangles in indirect measurement. So if you recall, similar triangles were triangles that were the same shape, but they were different in size. And because they were the same shape and just different in size, their angles are the same and their side lengths should be proportional. So let's take a look at two similar triangles. I'm going to make a large triangle. Now this is just a sketch, so bear with me. I know that you may say, well, they're not exactly the same shape. I'm trying my best to make them look the same. I have A, B, C, and we'll call the little one D, E, F. The angles in ABC are 65, 95, and 20. And the angles in D are 65, 95, and 20. So the key idea of this section, we'll actually write it down, is that when two angles in one triangle are congruent to two angles in another triangle, the third angle is also congruent. So if you're looking at two triangles and two of the angles of the same are the same, the third one must be the same. If I have a triangle and its angles are 50, 75, and X, and then I have another triangle whose angles are 75, 50, and Y, I know right away that the two triangles are similar because they have two angles that are the same. I'll highlight those for you. This triangle has an angle of 50. This triangle has an angle of 50. This triangle has an angle of 75. This triangle has an angle of 75. Even though one's larger and it's been turned to a different orientation, two angles are the same. So the third angle must be the same. And we know that's true because every triangle can only add up to 180 degrees. There's only one other thing I can add in here to make 180. There's only one thing I can add in here to make 180, and that has to be the same. Makes sense, right? Let's try a second example. I'm going to make numbers different on this one. I'm going to start with a big triangle and then have a smaller triangle. And the angles in the big triangle are X, 63, and 54. And the angles in the smaller triangle are going to be 63, 63, and Y. And I want to know, are these triangles similar? Are they similar? Well, they both have an angle that is 63 degrees. This triangle has an angle that's 54, and this triangle has an angle that's 63. I know that every triangle must add up to 180 degrees. So I'm actually going to find out what x would have to be to make 180. So I'm going to write an equation. X plus 54 plus 63 equals 180. That will tell me the one thing that this could be to complete the triangle. X plus 117 equals 180. So in this case, x must be 63. So that means that the three angles here are 63, 63, and 54. Well, right now this triangle has 63 and 63, so y must be 54. Because this has two angles that are the same, these triangles have two sets of congruent angles. So the third angle must be congruent. It has to be. The only number I can put in here is 54. 63 plus 63 plus 54 is 180. That means that these two triangles are similar. See if we can fit one more on the bottom of the page. For this example, I'll give you two right triangles. We'll have this one. We all remember this means 90 degrees. It's a right triangle. And I'll try to do one that looks bigger. Again, I have a 90-degree angle. This small triangle is going to have x and 42. And the bigger one is going to have y. Oops, I should put y down here. Y and 38. Is that hard to read? We'll go like this. 38 degrees. So I'm first going to find out 90, 42, and what makes 180 degrees. I'm going to solve this to find x. X plus 132 equals 180. So x in this case must be 48. So x has to be 48. All triangles add up to 180. 42, 90, and 48 together add up to 180. That's the only number that could work. I'm going to start comparing the angles of these triangles. They both have a 90-degree angle, but they don't have a second angle that matches. This angle's 38, this one is 48. We're not sure what this one is, but even if it was 42 or 48, they'll never have three matching angles because this one is 38. I can solve for that missing angle. One 28 plus x, equals 180. X must be 52. Because they only had one congruent angle and not two, you can see that the three angles do not match. These are not similar. I hope my math was right on this one. We'll double check. All right, so when two angles in one triangle match two angles in a second triangle, the third angle must also be the same. That's what we know about similar triangles. Now, indirect measurement is finding a missing measurement based on information that you know and not measuring it directly, but indirectly. So something like the height of a tree. If I wanted to know the height of this tree, I'm going to call it X, and I know that this person is 5 feet tall, and you can see that this tree that is X feet tall and this person that is 5 feet tall, they're both casting shadows. The tree shadow comes out here, and this person's shadow comes out here. So probably the sun is up here somewhere, casting its shadow. Now, looking at these, I'm going to use a highlighter because I can see two different triangles. I can see the height of the tree, its shadow, and the sun's ray. The person, on the other hand, I can see they have their height, their shadow, and also the sun's ray. Now, if I were to draw these a little bit smaller down here, the person's looks a little bit like this, and the tree looks something like this. Now, the tree and the person share some common information. They're both perpendicular to the ground, so they both have a 90-degree angle, and they both are getting hit by the sun from that very same angle. So that top angle of both triangles I know is the same. Now, what you just learned in the last chapter is that if two triangles have two angles that are the same, the third angle must be the same, which means they are similar triangles. Now, there would be some more information given to you. If I told you that a 5-foot person casts a, let's see, 7-foot shadow. So this is 5, and this is 7. And then the tree, we don't know how tall it is, but it casts a 21-foot shadow. Now, I'm doing these all in feet. Be careful. Sometimes you will be given a problem, and some of the dimensions will be in inches, and you'll have to convert them so that they're all the same. So if I told you that that was 7 from here to here, and the whole thing is 21, that's where those dimensions came from. So because I know that these are similar triangles, because they have two angles that are the same, I can write a ratio of corresponding sides and make a proportion to solve for that missing value. X to 5, the height of the tree to the height of the person, the shadow of the tree, the shadow of the person. A ratio of corresponding sides. And now we cross multiply. 7 times x is 7x. And that should be the same ratio as 5 times 21, which is 105. Divide both sides by 7. And x equals 15. So the height of that tree would have to be 15 feet. The one in your book showed a person and the sun's ray and a flagpole and the sun's ray. Now the same thing happens in this situation. They're both making a 90-degree angle with the ground. That's one angle that's the same. And they're both being hit by the sun from the very same angle. I know that because they've told me that the rays from the sun are parallel lines, which means they're hitting at the same angle. So because the 90-degree angle is the same and that top angle is the same, these two triangles are going to be similar. So if I were to draw them again, 5 to 3, the person was 5 to 3, 5 feet tall, a 3-foot shadow. The flagpole is X feet tall, and the shadow is 36. The flagpole is X feet long, and the shadow is 36 feet. So because these are similar triangles, they have two angles that are the same, I know that third angle must be the same. Because they are similar triangles, their side lengths are proportional. So I'm going to write a ratio of corresponding sides. 5 to X and 3 to 36. The ratio of the height to the height and the base to the base should be proportional. When I check the cross products, x times 3 or 3 times x is 3x. 36 times 5 is 180. Divide both sides by 3. And that flagpole must be 60 feet tall. So using indirect measurement is using the height of something you know to find the height of something you don't know. So as long as you know that two triangles are similar, you can write a proportion to solve for the missing side length.